Okay, morning class. Welcome to trigonometry, the subject where math meets the real world and where triangles become your new best friends. I'm Sir Amir, your navigator in this exciting journey through angles, sides, and functions. Trust me, by the end of this course, you'll see the triangles in your dreams. Now, what is trigonometry? Trigonometry is a branch of mathematics that studies the relationships between the angles and sides of triangles, particularly right triangles. It focuses on understanding and applying these relationships to solve problems in geometry, physics, engineering, and other fields. The word trigonometry comes from the Greek words trigonon, that means triangle, and metron, that means measure. Okay? Trigonometry is what architects use to design buildings, what pilots use to navigate planes, and what engineers use to construct bridges. Even your phone's GPS relies on trigonometric calculations to find your location. In short, trigonometry connects the abstract beauty of mathematics to the practical needs of our world. Now imagine you're standing in a park and you see a tall coconut tree. You can't climb it, though some of you might be tempted, but you need to know its height. How would you do it? By using trigonometry, specifically the tangent function, and a little clever measurement from the ground, you can calculate that height without ever leaving the ground. That's the magic of this subject. It gives you tools to solve problems you thought were impossible. Now let's talk about what you can expect from this course. We'll start with the foundation, angles, regions, and the unit circle. Then we'll dive into the trigonometric functions, sine, cosine, tangent, and their applications. Eventually, we'll explore identities, equations, and even some real world problems. My goal is not just to teach you formulas, but to show you why they matter and how you can use them. By the end of this semester, you not only master the skills to ace this course, but also gain a new appreciation for how mathematics shapes the world around us. Now, let's have the special angles. So what are these special angles? Special angles are specific angles in trigonometry with well-known and easily calculated trigonometric values. These angles are commonly used because they simplify computations and are fundamental uh, the, to the operations uh, related to trigonometry. Okay, so we have the examples here. We have 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so why are special angles important in trigonometry? So we have the following reasons. First is trigonometric identities and patterns. So there are special numbers that you can maintain and you can keep the complete decimal values. And we have also the building problem solving skills by using the values related to the special angles. It will be easy for you to solve the the values without compromising the accuracy. And we also have the last reason, connection to other mathematical concepts. So it can really, the special angles can really be used to solve problems related to geometry and other fields of mathematics. Okay, so now let's start with the properties of 30, 60, 90 triangle. So by using this triangle, you will be able to see why 30, why angles such as 30 degrees and 60 degrees are special. Okay, so let's have the first property. The side opposite the 30-degree angle is half the hypotenuse. Second property, the side opposite the 60-degree angle is square root of 3 times half the hypotenuse. So why is it that 1/2 and square root of 3, why they exist? How are they derived? So I will show you. So let's start with the equilateral equiangular acute triangle. So we can see that there are three 60-degree angles and each side measures S unit. And let us construct a perpendicular bisector such that the angle on top, the 60 degrees, will be divided into two smaller acute and congruent, uh, two smaller acute congruent triangles, 30 degrees and 30 degrees. And this perpendicular bisector dividing the side opposite 60 degrees. So you can see that the perpendicular bisector divides the opposite side into two segments, and each segments measures 1/2 S. So you can see that the acute triangle is divided into two congruent right triangles. So we can just take one right triangle, and you can see that uh, you can see the first property, and you can see that the side opposite 30-degree angle is 1/2 the measure of the hypotenuse. 1/2 exists because of dividing the opposite side into two equal segments, and each segment one measures 1/2 S. If you add 1/2 S and 1/2 S, it will give you the original measure S unit. Now let's assume that we do not know yet the second property. We do not know N. So I will show you the why and how of the number square root of 3. So let's apply first step Pythagorean theorem. Let C equals to S, that is the hypotenuse. P equals to 1/2 S. This is pertaining to the side opposite 30 degrees, and A equals to N. And this side uh, is pertaining to this is the side opposite 60 degrees. Now let's have the substitution. Okay, let's have the substitution, and then the application of the properties of the law of exponents. And then we have here n squared plus 1/4 s squared equals to s squared. We're not done yet, so we still have to transfer 1/4 s squared to the right-hand side, making it a negative term. Now we have n squared equals to s squared minus 1/4 s squared. In the right-hand side, you can see that s squared is the greatest common factor, so we can just factor it out, leaving only the expression 1 minus 1/4. So 1 minus 1/4 is 3/4. So in the third line, third row, you can see the equation n squared equals to 3/4. That number multiplied to s squared. We're not done yet, so still have to get the square root of both sides. So after the application of the square root of both sides, we have n equals to square root of 3/4 times s squared. Okay, so the radical sign can be distributed to the factors of a pure multiplication. So we have then n equals to square root of 3 divided by 2 times s. Or we can rewrite the expression in the right-hand side. We can write the right-hand side expression into a square root of 3 times 1/2 times s. So this proves the second property. By using the equation n equals to square root of 3 divided by 2 times s, we can see that the side opposite 60-degree angle is square root of 2 times half the hypotenuse. In other words, the side opposite 60-degree angle is square root of 3 times the measure of the side opposite 30 degrees. Now let's have the properties of 45-90 triangle. So you can see here the property. The measure of hypotenuse is square root of 2 times the measure of any leg. Okay, so I will show you the why and how of the number square root of 2. So we can start with a square. You know that a square is a quadrilateral with 4 equal sides and 4 equal angles. So we can see that there are 4 90-degree angles, and each angle measure 90 degrees. Then we can see that each measure of each side of the square measures S unit. So we can construct a diagonal bisecting two right angles. And after the construction of this diagonal, you can, by constructing this diagonal, you can see that the square is divided into two isosceles right triangles. Okay, and the measure of the legs, the measure of each leg is still S unit. Okay, we assume that we do not know the measure of the hypotenuse. Now we can just take one isosceles right triangle and let us solve the measure of the side opposite the right angle, and that is n. So you may wonder, how is square root of 2 derived? Let us continue. Okay, let's apply the Pythagorean theorem. Then let's have the substitution. And after the substitution, we will have the equation s squared plus s squared equals to n squared. So we have here two equal measures because we're dealing with the isosceles right triangle. We're talking about the legs, two congruent legs. And then in the left-hand side, adding two similar terms, we have 2s squared in the left-hand side equated to n squared. And we can just switch the places. We can have n squared equals to 2s squared. We're not done yet, so you still have to get the square root on both sides. So the square root of n squared is n, and the square root of 2 squared can be equal to square root of 2 times square root of s squared. Take note that 2s squared is a pure multiplication, and it is the product of number 2 and the product of the monomial s squared. So take note that if you're dealing with a pure multiplication, if you get the square root of it, you can just distribute the radical sign to its factors, as long as there's no plus or minus sign in between. Okay, then we have n equals to square root of 2 times square root of s squared. Square root of 2 can be as is because it is an irrational number. Square root of s squared is s. So we can see here that n equals to s times square root of 2. That n here is the hypotenuse, the measure of the hypotenuse. S is the measure of any leg. So we can really see here that the measure of the side opposite 60 degrees is just equal to any leg multiplied to the number square root of 2. So we can now see how is square root of 2 derived because of the application the uh, of the radicals. Okay, class, I hope you enjoy listening to our first lesson. Next topic will be um, situating these special angles to the Cartesian plane to show you the standard position of an angle. So may God bless you, class. Have I hope you enjoy and learn many ideas right now. Thank you very much. May God bless you. Thank you very much.